So this question was asked in GATE 2017 Electronics and Communication Engineering paper set 2, in which you have given an LTI system whose magnitude response is h of f, which is given by this equation. Also, the phase response of this LTI system is given by minus 2f. So now the input to the system in the form of sinusoid. So you need to find out the average power of the output signal y of t. So the NPTEL reference for this question is Control Engineering by Professor Ramkrishna Pasumurthy. You can find reference in the lecture in the introduction to frequency response. So now the useful data for this question is, if you have given a LTI system and if your input is in the form of sinusoid, which is equal to a sine omega naught t plus some angle phi. Now, if the LTI system frequency response is given by h of omega, then your output y of t will be given by a into magnitude of h of omega naught, that is magnitude of this transfer function at the input frequency, that is magnitude of h of omega naught into sine omega naught t plus phi plus argument of this transfer function h of omega at the input frequency omega naught. So this is the output when you applied a sinusoid as a input to the LTI system whose frequency response is h of omega. Now if you take the cosine here, then this becomes cosine. So this is the useful data for this question. Now coming to the solution of this question, you have given magnitude of h of f is 1 minus mod of f upon 20, where f is from minus 20 to plus 20, that is mod of f less than equal to 20, and 0 for mod of f is greater than 20. This is the frequency response of your LTI system. Now you are putting input x of t as the sinusoid to this LTI system, where x of t is given as 8 cos 20 pi t plus pi by 4 plus 16 sin 40 pi t plus pi by 8 plus 24 cos 80 pi t plus pi by 60. So this you have given as xt in this question. Now for the first signal, that is 8 cos 20 pi t plus pi by 4, your f naught is given by 10. Now your magnitude of h of f naught will be 1 minus 10 over 20, which is equal to 1 minus 1 by 2 equal to 1 by 2. Angle of this h of f is given as minus 2 times f, which is equal to minus 2 into 10, which is equal to minus 20 degree. So your output corresponding to this input 8 cos 20 pi t plus pi by 4 can be given as y1 of t equal to a times magnitude of h of omega naught or f naught into, as this input is cosine, so output should be also in cosine, cos of omega naught t plus the phi, which is the input phase, which is already present in the input phi, which is represented as phi plus angle of h of omega naught. So when you put magnitude of h of omega naught and magnitude of h of angle of h of f in this expression, you will get equation as 4 cos 20 pi t minus 25 degree. So this is your uh, output for the first first sinusoid, that is 8 cos 25t plus pi by 4. Now for the second, that is 16, sine 40 pi t plus pi by 8, your f naught is 20, and the magnitude of h of f at f naught will be 1 minus mod of f over 20. So it becomes 1 minus 1, which is equal to 0. So when magnitude becomes 0, then your output will be 0, because this magnitude of h of f naught will be multiplied to a into magnitude of h of f naught. So this y of t becomes 0 due to this input 16 sine 40 pi t plus pi by 8. Now for the third input, that is the third sinusoid, which is given at 24 cos of 80 pi t plus pi by 4, here your f naught is 40 hertz, but your magnitude of h of f is given as minus 22 plus 20. It is 1 minus mod of f over 20, but 0 otherwise. Other than this frequency, this magnitude response is 0. So your f naught is 40 hertz, so output will be 0 for this frequency also. That is, for f naught equal to 40 hertz, your output will be 0. So your total output y of t will be given by only y1 of t, if this is y3 of t and this is y2 of t. So your y1 of t, which is due to the first input, that is 8 cos 20 pi t plus pi by 4, output due to this input is given as 4 cos 20 pi t minus 25 degree. So this is your overall output. So this is your overall output y of t. So the power in this y of t signal is given by 4 square over 2, which is equal to 8. So the correct answer for this question is 8.